Hi, this is Jeroen, and this is Anchormen's AI journey. Tune in to get inspired by the opportunities, impact, and capabilities of data, machine learning, and artificial intelligence. Together with my colleague Ron, we will be talking about developments, best practices, and lessons learned from the field. So get ready. All right, welcome back, listeners. This is the AI journey. Today we have our guest, Corné Versloot, and of course my trusted co-host, Ron Dodge. Welcome, Ron. Our guest, Corné, just as a small introduction, respected colleague at Anchormen. We joined around the same time, actually, at Anchormen. Before that, he worked at TNO, where he did computer vision based on Apache Storm. Very cool project, a bit out of scope maybe for this episode, but definitely very cool project.
One of the things. I focused more actually on text and text mining and retrieval. And not so much on video.
Oh, really?
But this was one of the very cool projects. So it was about scalability for one of the first times in my career.
Well, let's and then you joined Anchormen already over 5 years ago, and I think one of the also very notable output was the Elasticsearch SQL driver, which was actually very popular until Elasticsearch came out with their own SQL driver, right? Corné, do you miss Hadoop?
No.
No? Why not?
No. So so Hadoop. I started working with Hadoop already in when I was still working with TNO, and then continued that with Anchormen. Did like 2 or 3 projects, primarily on-prem with Hadoop, and it's very powerful technology, and I think it really brought us where we are now. But it really requires a lot of administration, management. It's complex to understand it and everything around it. So that's a downside of it. And now, looking what I'm doing right now, that's a lot easier. So that's why I'm saying, do I miss it? No.
Yeah.
Sorry for being the data scientist in the room, but what is Hadoop?
It's an elephant.
Oh, I didn't get that.
Toy elephant. No.
Yeah, that's the icon associated with Hadoop. Yeah, what is Hadoop? That's one of the hardest questions.
Was the first kind of big data storage and processing platform. And it came out of a white paper published by Google. Google was seeing like, hey, we're running circles around the competition and we need a healthy ecosystem for us to also thrive, right? So we need to get the others on board. Plus, they kind of wanted to signal to potential recruitees what they were working on. So they published this white paper, and then someone else, I think working at Duck...
He was hired by Yahoo.
He was hired by Yahoo, and he then implemented this in Java, and that became Apache Hadoop.
So it's distributed storage and distributed processing, because basically Google had this issue with the size of data that no one in the world really has or had. So they built their own technology, and these bigger tech companies still do that. So a lot of our open source comes from like Google, LinkedIn, some of it, Facebook. And others.
I knew that.
Oh.
Then why do you ask? No, but so and actually Anchormen was at the forefront of the big data wave in the Netherlands. So we did some of the first big data projects in the Netherlands when we started our careers at Anchormen.
Yeah, we did some of these projects together.
Yeah,
Jeroen. Yeah, true.
So that was, but the problem with it was that there were just a lot of components, a lot of moving parts, and you had to configure a lot, which of course meant a lot of flexibility also, but it also meant setting up a lot of work before you could actually start delivering business value, and that's also a bit of space. So you could download vanilla Hadoop, right, which was. It was open source free. You could just download it and then kind of configure it to your needs, which was complex. Although, it was easy to get it up and running, but to really get it like to production grade, that was complex.
So I can't help but notice the past tense that you guys are speaking in about Hadoop.
Right, exactly, because it's kind of, on the processing side, it's been taken over by Spark already for a while, and now on the storage side also since a couple of years, it's been taken over by cloud providers. You have bucket storage, things like
Blob
Azure Blob
storage.
Storage, S3, Google Buckets. These all, and they even offer the HDFS, which is the Hadoop file system protocol. To interface with them if needed. But yeah, you don't need to think about hard drives anymore, or downtime, or networks,
that's really the cloud situation. In the cloud, there's a lot of other options, which are, some of them are like other technologies, but some are like 100% based on the same like big data stack. Sometimes they're just cloud implementations of it. But if you're looking in the on-premise situation, I think there's still a place for Hadoop there, where you don't have all these cloud, flexibility. And if you do have the need for distributed processing, large-scale storage, for sure there's still a place for Hadoop. And in the trainings
what version are they at the moment? 4? Is 4 out? Am I less?
I don't think so.
I
don't know. So
last.
that's I haven't really been into that for more than a year now.
Yeah,
or 1.5 years,
maybe longer.
But in the trainings that I do for our academy, and sometimes also for the training that I do for cloud-based training for customers, there are some slides around Hadoop. I call it a little bit of a history lesson, but I do appreciate really what it brought us, and the way of thinking also about how we can handle data that not normal relational databases. That's not the only golden solution. There's other ways to think about data storage, data processing, and it requires different technologies as well. And now that people has engineered these technologies and are now in the cloud, that has a huge benefit.
But the principles still hold, right? Distributed storage, redundant storage of blocks, also distributed processing, MapReduce. A lot of these principles still hold.
Yeah, for sure. And a lot of I think.
By the way, MapReduce was actually thought of in the 70s. It wasn't something Hadoop came up, but they were able to do it in a very scalable way.
Yeah, Google just made I think the first like really distributed implementation of it. And even Spark, right now people think of it as a standalone technology, but I think it really originated from basically also the Hadoop domain. People recognized there were some downsides in MapReduce, in terms of speed, usability. It was really hard to write, really hard to maintain. And that's the problem that these guys solved, in essence. MapReduce was too hard. We make something else. That's now Spark. Mm-hmm. And now Spark is a standalone thing, but it does come from this same ecosystem. That's where it originated from.
So for the listeners who also were interested in the answer to the question, what is Hadoop? Can you maybe also explain what is Spark?
Spark is a distributed processing, I would say, framework.
And it's different from Hadoop in what way?
So Hadoop, again, what's with all the hard questions?
We're only getting started.
It's a test. It's a test.
So Hadoop, in my mind, Hadoop, what makes it hard is that Hadoop is not one thing. Hadoop is an ecosystem. A lot of people think of Hadoop as one thing, and typically when you ask what's Hadoop, people say storage. But in essence, that's why I refer to the Hadoop ecosystem. It's overall, I would say, over 20 or 30 different technologies that all fit together, that enables people, customers, organizations to work with very large data sets.
Well, it definitely has a lot of different meanings, the word. I think because if you download the vanilla Hadoop project, you get storage and MapReduce. But there are so many, with these distributions, so many components that kind of work together with it that also go under the nomen Hadoop. So Apache Spark is actually kind of the evolution on the processing side, where you would do, have one of the downsides was that all the results between the stages of map and then reduce and then map and then reduce needed to be serialized to hard disk, which, as you know, is very slow. Yep. And one of the big breakthroughs, they have many more optimizations, is that Spark keeps it in memory. So
it's an evolution basically of MapReduce as an original technology, and you see that with more technologies in the Hadoop ecosystem, which are in essence, as is with all technology, they're just evolutions again and again. I'm not sure if we now have answered your question, Ron, to be honest.
Well, the reason I brought it up is because doing these projects for Anchormen, we of course learned a lot about storing data and processing data at scale. And this has been kind of the precursor, what we learned there, for the project that Corné is currently leading, which is our data hub. So this is kind of the building up the bridge to our data hub solution. Corné, what is the data hub?
The data hub is our like cloud native big data platform. In essence, it enables our customers to do basically the same thing as what they could do with Hadoop, but then in the cloud and using cloud native technologies. So like scalable storage, scalable processing. That's really no issue there. You only pay for what you use. So it's really a pay-per-use basis. You don't have to, first buy 10, 20, 30 servers upfront. So and it's very easy to set up as well. So we've got everything scripted. So right now we can set it up in like roughly 2 hours if everything is in place within the Azure environment that we're using. Then you've got everything. You've got storage. You've got monitoring on that, and you can really get started with your data projects, getting your first data sets in. So it's really an accelerator compared to what we used to do before, with Hadoop, but also with really like greenfield cloud.
In the beginning, you would work for a month before you could even deliver your first use case, and then
or longer. I've been in projects that took over 6 months actually to get started.
And now
not to get started, but to get started with your first
to get started, to actually
with your first data use case. Because there's a lot of stuff that sometimes you need to do in terms of so getting hardware, but also designing, getting sign off on your security, on privacy, all of these things that matter, when it comes to data.
Governance.
Governance, exactly.
So Data Hub is something that sits on top of a cloud platform like Azure, AWS, right?
Yeah, exactly.
And it's, what is it? It's software, it's infrastructure. What would you call it?
Well, I would say it's both right now. So the first bit is infrastructure, using and configuring the right Azure or cloud. I'm focusing really on Azure. That's why I refer to Azure, but it's about cloud services. Which storage to use, how to configure it, how to secure it, which compute to use, how to integrate these things, etc. That's a lot of infrastructure or using and configuring cloud services. Once you've got that, then you can start building your data pipelines, your data use cases and applications. So the first bit is a little bit infrastructure focused, but right now, because we're doing and have been doing a lot of these projects, we also start having different like pre-built pipelines already, pre-built connectors to different systems, which might not be existing in the cloud yet. So we also bring these to accelerate really the project. So it's a little bit of both.
And maybe also kind of relating to our previous episode, what is a big advantage of Anchormen's Data Hub solution is because it can be rolled out so quickly, you also take a different approach towards integrating it into the organization. So the organizational side of it, they don't need to reinvent the wheel. So there is it leaves more room for maybe organizational discussions and less about organizational and technical discussions, right? So it's very easy. So it's easier to navigate the politics within an organization.
Because for Data Hub, already many decisions have been made that adhere to best practices, and
correct.
And so you don't need to think about those kind of things, and then you can think about actually the value that you want to add on top of when you want to use it.
Yeah.
And then of
it's
course
not always true, but
everything's configurable. But I would argue even that you could say that it's easier to adjust then the organization to the best practices instead of the best practices to the organization.
And so an organization would need a Data Hub when? Like why would an organization need a Data Hub?
When they have the ambition to utilize their data more and more. So if they've got a strategy over a couple of years in which they really have some concrete use cases in which they want to use their data, whether it's for recommendations or to improve the way that they interact with customers, or more on the machine side, if they want to at least store logging from machines and then do predictive maintenance on it. If they've got this vision, then the data hub could really be a solution for them.
How? So how would the data hub help them achieve that?
So the data hub has all of these, so already the infrastructure and best practices that we bring to basically for them to store and build these
maybe
applications.
I think this is also a good point to explain data silos. What are data silos within an organization, and how does the data hub breach those?
So data silos are essentially the different like applications that you have within each organization. They're often referred to as silos. A database, an application, and it really has a purpose.
Marketing has their database. The warehouse has their database. Procurement has their database.
Isolated, which is why
they're isolated. And the moment you want to do a little bit more with your data, like nine times out of 10, you need to combine, some piece of data from these different systems.
I know.
Yeah, you've got a data science background, so that's like 80% of the work that you do. But getting this data, and that is exactly one of the things that a data hub, but also Hadoop, would solve. It would enable you to get all this data in a single place where you can combine them and do your analytics on them without burdening the operational systems. There's sometimes a question that I get from people. So, we like to minimize data movement, or in Dutch, data sleur and pleur. So typical architects might, ask this question: why not leave the data there where it is, and then we just get it when we need it? But there's, that's technically for sure possible. But there's the risk is that it's an operational system. You don't want like some data science just running a big ass query on that operational system. And typical data science, involves large data sets. You're not interested in one or two records. Typically, give me the full history of what all customers has done in the past 3 years, aggregated on whatever their expenditure. So these are heavy analytical queries. You don't want to put that pressure on operational systems. So you want to make this distinction between the two. Get the data out of the operational systems because they are primarily meant for operations, and put them in an analytical environment where you can do your analytics, which is also, really built for this type of queries, this type of data.
And you want to keep it fresh, right? Your data.
Yeah. So you keep this data updated either like on a daily, hourly basis, or even streaming
automatically.
Automatically.
So the primary purpose of Data Hub is to facilitate analytics. Is that what you're saying also? Or could you do operations on Data Hub as well?
I would say primarily facilitate analytics, but then also the analytics, that facilitate operations in that sense. If there's no real need for analytics, if it's just maybe storage or just moving data from application A to B and C, I would say there are different solutions for that. That's more like a middleware type of function.
Enterprise service bus.
Yeah, enterprise service bus, stuff like that. That is really a different role that you're looking for. What we do is really focusing on enabling the analytics, doing machine learning, and being able then to distribute, results back again to other applications.
And ideally, you want the results of those analytics also fed back, of course, into the production system, right? Where you do the scoring, the churn scoring, or maybe the recommendations that you computed. You want that to go back and not only have, for example, obviously reporting and dashboarding is very valuable, but you can get so much more out of your data hub if you automate the results back into production systems.
Yeah. But so I would say the distinction really between operational and analytical. At some point, analytics becomes operational.
Yeah, if you're truly data-driven, right?
Yeah, exactly.
Then it's no longer a distinction.
No. Yeah, exactly. Yeah. And that's something to be aware of, because sometimes, you have this little bit of this view of the world. Is it operational or is it analytical? And then people tend to think of it about really in terms of dashboards and stuff like that. Well, in the end, I would say so. For sure, there's a lot of value already, in using dashboard and getting the right insights into the right people. But I would say then the next step would be to utilize your data in really the business processes of your organization.
So that would be like you use your data hub to do analytics, build models, create. You can even deploy right? A machine learning model that does predictions, and then that deployed machine learning model on Data Hub can then be queried by production systems or by operational systems.
Exactly.
To then, in that sense, Data Hub is also
either
integral.
be queried or you proactively push the results back. It depends on the use case.
But then from that point onwards, Data Hub is not just like for monitoring or dashboarding, but also like a gear within the entire operational system.
Yeah.
Right. Yeah. Okay, I see.
I would say usually, it starts out as a relatively small gear in terms of its importance. I mean, it can be big in terms of the amount of data that it has.
Yeah.
But you start with recommendations and stuff like that. But that doesn't really directly hurt your business if it's not working for an hour or a day. But what we see over time, this gear, the size of it grows and becomes more and more important as well.
Well, so I wanted to ask you maybe if you can you take us through a typical use case? I mean, you've mentioned recommendations now a couple of times. Maybe you can take us through a typical use case there, from click to showing the recommendations, or maybe a different use case where that kind of also illustrates the role of the Data Hub in there.
So I would say there's a lot of different use cases that we currently have and currently doing. So maybe just to talk about a couple of them.
Mm-hmm.
I would say one of the first type of use cases typically have to do with insights at some point. So they're really usually more BI oriented, in which we have our Data Hub, and we get our data in from source systems. Either we pull them or they push them. It's really a discussion. Then we harmonize that data and we basically change it in such a way that it can be used.
What does harmonizing mean?
I would say
deduplication.
Deduplication, cleaning the data, making sure that the different fields, if they've got like IDs or timestamps, that they are like in the same format, stuff like that, so they can be related to each other.
And when you say we do that, you mean you set up the system to do that?
Yeah, exactly. So we build the pipelines, which can be, depending on the type of technology, what we can use, can be really simple drag and drop. For integration, that's what we typically use, and at least in Azure, we use Data Factory to get our data in. That has over 80, 85 connectors to all kinds of systems, so that you can really easily drag and drop connectors there and just pull your data in. And then when it comes to real processing, we can either use Data Factory or use Spark if it's bigger data sets, and then we use Spark to do this work. Once we've built it, test it, then it runs like on an orchestrated basis, hourly, daily, and you end up with clean data set. That's in the end what we want. Clean data sets on which you can build basically all use cases. So this step, you always need to do this essentially.
Yeah. So this step is just to get the data in an accessible form on the Data Hub.
In an optimized...
This can be the clicks on a website, for example. So the behavior user is
and an optimized, automated, robust, that's what you're doing. And that means that then after every time I am going to access the data, I'm going to see the most recent version of those
the
data.
most recent version. And there's also a piece of governance around it. Obviously, sometimes the source system fails or something fails. So you want to be notified when this happens, but also be able to rerun, just that single data set, without having side effects. So this is where our best practices actually come into play, because this is not handled by the technology itself directly, but just the way that you have to build it correctly. But you end up, the goal here, you end up with a nicely organized, optimized set of data that you can then use for example, to build dashboards on, or push it to a data warehouse.
And exactly. And keep in mind that once you have such a data stream in your Data Hub, you can start using it for other use cases as well, right? So it's I always like to give the analogy of putting strings on a guitar, right? So your first use case is the first string, and you can make some sound with it, and then you add another string on your new guitar, and then you can already do some different kind of like variations.
That's a good one. I didn't know this one.
You've never heard me say that one before. And then you can do like a third string, and you can do melodies, and then a fourth string, and then you really start to make music with it. But what's important also about this analogy, which is one of the philosophies also behind the way we do our data hub projects is that you need to do the string end to end. You cannot start attaching all the strings just at one side and then leave them hanging. It's very important that you add a string from beginning to end, so that string already can make a sound.
Right. So the guitar is a data hub. The beginning of the string is the data source coming in, and the end of the string is
use
your
case. I would say
use case.
It basically exactly the data is basically you do the use case end to end from beginning to end, and then when you have that in place, you can use that string also for other use cases, right? So you can make I guess the use cases would be the sound that come off it, and they become more and more complex.
And then you can get your 12-stringed or 20-stringed guitar to really play awesome music.
Yeah, and your guitar, but you have to build your guitar in such a way that it can handle all these strings as well. You know, that it doesn't break when you attach 120.
And
you don't want the string to be so strong that it breaks the guitar.
I see. And so I love this. So what's the if you talk about doing a use case end to end? So Corné, you just described the process up to getting your data on Data Hub, but then when you want to do a use case end to end, how would you describe that process?
Yeah, so this was basically the technical part of it. I would say the first part is to choose the use case. Typically, you know, most of our customers have multiple use cases already. You know, they don't ask us to build a data platform for only one use case. Now they have this vision, you know, for more and more data usage.
You might even say that one use case for a data hub is a bit overkill.
No, yeah, that would be. Oh, if that's just the ambition that you have, then you can just build that, you know, just that thing. Mm-hmm. So typically there are multiple use cases, and we start out with basically prioritizing them, understanding them, prioritizing them. You know, which one has the biggest value and moderate complexity to start with. I mean, especially when we come in with the data hub, you know, everything together, it's powerful, but it can also be complex. You don't want to build the most complex application right from the start. So you have to make this decision together, you know, with the organization, and then design it. Properly understand, you know, which data then do we need? Where does it come from? You know, do we have control over it? Because sometimes it has to come from third parties, external, Google Analytics, whatever. Make a little bit of a design. How does it come in? How do we refresh it? This is sometimes a step that is forgotten, which you should never do. Just think about it a little bit before you start building. So put it on paper, and then you can really start scrumming, basically, if in an agile way, building the different pieces that you need to get this data in, and transform the data, build the output data sets, whatever that is, and get it out. You need to have this entire idea and then build it step by step.
That's interesting also, if I can pause you right there, that you have the data go through different stages. Does data need to be stored raw, in your opinion?
Yeah. Well, it depends on your definition of raw, actually, but yeah. So the first step in which we store data is the data as it came in. But maybe the technical format might be different. A lot of our data comes in as, for example, CSV or JSON. And the first step that we typically do is transform that into Parquet or maybe Avro, you know, which have a lot of benefits from the analytical perspective because they're compressed, they have a schema, they have a lot of these goodies, which is very helpful if you then want to query and use that data. But content-wise, we don't change it because you don't want to make any mistakes because you cannot recover from those mistakes. Maybe we add some information when it was loaded, for example, if there was some kind of quality check, you know, what the output of that quality check was. So we add something, but content-wise, we store in the first layer, we store it.
Maybe to put that in perspective, especially with older data warehouses, people would connect a data stream and then would only focus on the fields of the data stream that they needed. But the problem with that is if you suddenly think of a new use case that could be beneficial where you need other fields in that same data stream, then you need to start collecting as of that point in time. Whereas if you store everything raw, you have the complete data agility to immediately start building that use case.
So that's a little bit of a best practice and advice that we give. If you know which sources you need and you start collecting them, you collect them as a whole. As far as you can, you're allowed to have them, right? There might be sensitive data in there which you're not allowed. Okay, then you have to exclude it. There are good reasons for it. But other than that, we grab everything. Because what you don't want is then, so if you would do this, basically you would do like half your string of your guitar. And then if someone wants to play a specific melody, you think, I need this first string, but I'm still missing something. And then you have to go through this process again. I'm missing something. And then you don't have the history. So yeah, that's really pitfall. You shouldn't really do that.
It's something that's possible now because of cloud storage and everything, but used to be more difficult because of the fact that your storage was limited.
It was
and expensive. Storage used to be expensive.
Yeah, exactly. So the fact that storage now is a lot more affordable. Some might actually call it cheap. That allows you to have this different view on what you grab, how you store it, how long you store it.
Everything.
Yeah, store everything. I mean, you can actually go into absurdities. Obviously, here you still have to think about it. But as a basic rule of thumb, certainly not in the beginning. Do not remove any of the input data. Just grab it all, because you never know down the line in 1 or 2 years if you might need.
Yeah, you don't know what your future use cases will be.
Exactly.
Yeah, and what is to go back to the use case part is the when you set up a data hub for a client, are you just setting it up until for 1 or 2 or X data sources, the data pipelines, and then you say, look, here's your data hub with your data. Good luck with it. Or is Anchormen also building the use cases, or is there variety there? What do you see happening?
There's a variety, but there's this little bit of a project framework that we now tend to use for the data hub, which is maybe good to tell you guys. So in our basically data hub starting project, let's call it like that, we do 3 things. So we deliver the data hub, basically the scripts, and we deploy it, or at least one environment, because you can have multiple if you want data separation, separate DTAP stages. It can become quite complex. But
DTAP?
Development, test, acceptance, and production.
Very useful.
So we hand over the scripts as well that we have for this, so customers can do it themselves. But obviously in the beginning, it's complex. So we do the first deployment, configure all of that, and we provide training for data engineers, data professionals, how we call them, so data engineers, data scientists, analysts.
If they have some.
Yeah, if they have. Usually there are some people, in this domain working, and basically we give them this 1-day training so that they understand a little bit what the data hub is, the different technologies that we use, how to use them. So it's partly theory, and we have a lab in which we actually build an entire pipeline, beginning to end, so people understand, everything that's needed to do that. It's 1 day, so it's really a getting started type of training. So this is one part. You would say once we've done this, we've got the foundation technically, and people have a little bit of an idea how to work with it. The second part then is to actually implement the first use case, and it's always part of what we aim for in our first project, because that's a success. Just having the data hub is not a success. Having your first insights coming out of it, that's a success. So then we help the customer building the first use case, and it really depends on the knowledge and skill and experience of the employees of the customer. Who does what type of work. But typically we tend to do like 70% of that work, because we know it, we can really accelerate it. And then we do this trick. We design the pipeline. We build the different steps, either together or we do it fully, and then we end up with an entire pipeline. So this is
help them also with the use case selection.
Yeah, you'll help them with the use case selection. I must say, usually there's some very high value, high priority use cases already, in top of the mind of everybody within the organization. So that's not the hardest thing. Build it and deliver it. And then there's a second part.
Build it and ship it.
And then there's a second part, which is I think also good to understand. So we have got everything scripted, so we can deploy. That's really fast. But in a bigger organization, in an enterprise, there's all types of things that you have to consider, like on the networking level. How do you integrate this thing with the rest of the organization? How to handle security, how to handle privacy, how many of these data hub environments you actually need. If there's some very strict policies for data separation. Data from domain A, sensitive
asking
data.
IT to open a port for you.
Sorry?
Asking IT to open a port for you?
In the end, you're really technical. At some point, that's where it leads to. But you do need to take this into account as well. So it really depends a little bit on the project. But what we've been doing for the last few projects, so we just deploy like a proof of concept version basically of it with our best practices. We do the training. We get started with the organization so that they can actually work with it. Learn the technology, learn the way of working, but at the same time, do workshops with architects, enterprise architects, security, networking architects, to really figure out, all right, if this thing grows and we want to really make it bulletproof and fitting in your organization, what needs to happen?
Because there's work at the organizational side to be done also, right? So for example, data governance, the data hub offers, you can govern your data on the data hub, but you still need to make decisions like, okay, what roles do we have? Who's allowed to edit? Who's allowed to view? And then once we have these roles, what are the members of those roles, right? That's not something Anchormen can answer for a customer. The customer needs to designate people, for example, like, okay, you're in this group, you're in that group, and this is the type of access you have.
Yeah, and on especially on data security, who may access which data sets. That's also so we facilitated, and technologies we use, make it possible to do this. But obviously, it's up to the organization to tell us, we have these domains and this team may never access this data, et cetera, et cetera. So you do need to talk about it as well. We shouldn't really forget it. The fact that we can deploy it and use it very quickly, very easily, does not mean that you have to just totally forget about these steps. And currently, in the last three projects or so, we do this in parallel because we can rebuild, the entire system so quickly. We can also just have this proof of concept thing, and together with architects and do design workshops, etc., decide, all right, we need something else because these two data domains should never be stored in the same data hub. Well, we can always then deploy a second one right next to it. But we do it in parallel, because if you want to wait with basically experiencing, the technology and actually getting started with your data, that will be the traditional approach. First, think very hard with a lot of architects, and that may take months before everybody can sign off on it. Oh, hey, right now it's a good plan. But in the meantime, you're standing still, and that's just a waste. So a lot of times right now, we just do this in parallel, and we accept that we might have to change the platform after the designing has been done, which is totally fine. You have this flexibility in the cloud to do so.
I was just laughing because you said that then we add another data hub next to it, but then you can add another data hub in front of that combines the output of these two data hubs, and in the end you kind of get this federation of data hubs.
Wow.
Which is not what you want.
No. No, but what you do see here, there's a lot there's some flexibility. We've got one customer actually that has basically a miniature data hub on demand for their business units.
What does it mean, on demand?
So a business unit or a team can request a data hub from the central IT.
Give me a data hub.
And then basically IT then, they have to do the technical stuff, but then like 2 hours later, they have got their own small data platform in which they are boss themselves. The cost associated with it is also allocated then to that team, which gives them a lot of freedom. IT also said, all right, so here's your own thing.
And you don't get silos that way?
So there's a risk here for silos, for sure. But it's because it's exactly the same technology. It's a normal data hub. It's the exact same technology as used by IT in the central platform as well. The idea is this enables this team, this department to build an experiment on their own. It's called a sandbox environment. But once they've built their thing, they can hand it over relatively easily to IT, so that the pipelines, the data sets can then be used within the central data platform.
I see. So they get deployed in the central data platform.
Exactly. And that's the goal. In the end, it should be deployed there, but there is a little bit
more
of an
like
opening for shadow IT.
I see.
Right? It's a development environment.
If they start using it for production purposes, then you have kind of a
silo.
Tumor.
So, but when I have my miniature data hub, I can still access data sources from the central data hub.
Yeah,
that's possible because it's all in the cloud. There's a different computer on a different network on a different server or whatever.
No, exactly. So this is we then provide like read access for this team on the central data hub, on the data sets that they have access to. This also avoids duplicating data. If you wouldn't do this, then you would need to grab this data from the central hub, put it into their sandbox, and every time you duplicate data, in essence, it means it's hassle. You need to update it, and you don't want to do that. So
sounds like there's a business case to be made for Anchormen to have such a data hub generator.
Well, we do.
So that we provide.
His name is Corné.
Might be. So this is actually the customer that. So we provided them the scripts. They did a little bit more on top of it, and some of the flexibility that we have in the scripts, they made it fixed because they exactly know how their cloud environment works. So a lot of the decisions, and customizations that we offer, they don't need to offer. They did a very good job in taking basically our basis and really making it suitable, for their organization.
So, go ahead.
No, so I have a statement for you. Data warehouses are becoming obsolete.
No.
Why not?
No, so data warehouses, I think, are a very important piece of working with the data and providing the insights on operational, but especially more on a strategic level as well. And the amount of basically harmonization, data plumbing that's needed to really get the proper insights and make sure that you really measure what you want to measure from all of these different systems. That is really, really hard to do. And the people working in this domain, the technologies that they have, are really suitable for that. So I really feel that a data warehouse and a data platform, whatever kind, they really fit together very well. They're really facilitating different use cases, different types of insights on data, and it's for sure not the case, at least not in my mind, that a big data platform will at some point consume like a data warehouse.
So what can you do with a data platform that you can do with a data warehouse and the other way around?
Scale up more easily.
So
that's what you can do with a data platform.
Exactly.
The data platform is easier to, but also to store semi-structured and unstructured type of data sets.
Which is what we're really interested in this era of machine learning and.
Plus, for analytics, you often need to read the data more than once, and in a data warehouse, there are certain restrictions in order to preserve the integrity of the data set, which is for a good reason, because you want it to be to have this integrity. But if you need to kind of reshape a data set over and over and reread it. For example, when you're training a machine learning model at scale, it's much faster if you remove those restrictions. But at the same time, those restrictions are definitely necessary in order to make sure that you have a truth that you can build on.
Insights. Like this type of data platform. So obviously you've got this scale out option for processing and for storage, which you don't typically have with data warehouses. This statement is becoming less true, I would say. Over time, you really see data warehouses using a little bit the same type of technology, like Snowflake. It's a little bit of a data warehouse, but really built, on the cloud using the same types of principles. A SQL layer on top of a scaling storage layer. So you do see that these things grow together or go towards each other a little bit, but still, I would say like a data platform more suitable for different type of storage of data, semi-structured, unstructured, and scale-out processing. And it's okay there if 100 data scientists at the exact same time read a terabyte of data. That's not something you can easily do with a traditional data warehouse. It's the type of pressure where that thing is not built for.
That's made really for ad hoc querying.
And they complement each other a little bit in the sense that you see these scenarios in which the historical data from a data warehouse, like for example data older than 5 years, 7 years, is stored in the data platform. Can often still be accessed there, still even using SQL, but it's no longer stored in the data warehouse where the price per byte is a lot higher, and it's cold data. It's not used that frequent anymore. So this also opens up, space, processing space, storage space on data warehouse again. So this is where they can also just, work together.
Yeah. I was thinking you were saying hundreds of data scientists querying terabytes of data at the same time. That brings me to another point: is like, what will a data scientist notice when his organization or her organization moves to a data hub from the previous situation, which may have been silos? Like, how does a data scientist then access the data through Data Hub? What does it mean for data scientists to start working on the Data Hub?
So I would say, first of all, especially once the data hub grows, they no longer have to really look for the data. At least not. They don't have to look in which database the data is stored in. It's stored in the data hub in one single place. And in terms of the technology that they use, so a lot of data science currently still use their laptop a lot. Local Python, local R, make then connectors to these different silos to grab the data in. So first of all, they don't have to have all these connectors anymore, just one place. But at some point also the size of the data basically is too big for a single laptop. So we also provide them with the compute environment where they can log in, they've got their own notebooks, and they can do their work essentially at any scale that they need.
So they can quickly scale up a cluster that they work on, and are they forced to use Spark?
No.
No? So how do they do, and of course I know because I've worked on Data Hub and it's a pleasure to work on it, but if you're used to your Python or your RStudio distribution or whatever, can you still do that on Data Hub?
Yeah. So there's the core, especially the scalable processing, what we use is Spark. And we use a lot of Spark SQL as well. So the data sets, the way that we store them, the way that we access them, is preferably through a SQL layer, so databases and tables, instead of just, hey, I want CSV files from here or JSON from here. Just working with a SQL layer is a lot easier easier to do, and you can access the data like it's a normal database. So you can essentially, from every type of solution, like an RStudio server, connect to Spark as if it's a database. Let Spark then do the distributed aggregations, whatever you need on the data, and just provide you then with a smaller data set.
And then you continue on working on Data Hub and on the cloud, essentially with your computations, right? There's no need to actually download that and to start working on your laptop.
No, so we can also provide like an RStudio server or the Jupyter environment in the cloud as well. But there's no real need for it. I mean, from security perspective, it might be needed, that the data doesn't leave the cloud, that it always stays there. So it can be provided, or it can be done from a local laptop. And I think this is really, this way of working is really where we're going.
Right. So, and notebooks, yes or no, on Data Hub?
Yes, we use them a lot.
Actually, for prototyping. Not for putting them in production.
Oh, really?
Yeah. No.
Are you in agreement with this, guys? Corné, what do you think?
Essentially, I would say we're in agreement right now. If you look at the notebooks that we use, so that's primarily Databricks notebooks for working with data. We use them in production as well. And there's some pros and cons on it. I think the biggest pro is it's so easy to do. The con has to do with the quality that you can have in testing on this code.
All good things always start with it was so easy to do.
No, famous last words.
Yeah. So you mentioned already a bit the way things are where things are going. What is the future for this domain? What's the future of the Data Hub, but maybe also data processing in general? Where is this going for organizations?
For organizations, I would say that we see the use and especially the maturity of these technologies and the way that we use them. We start seeing that a little bit more. So the technologies in itself are relatively mature, but not always 100%. But I would say, especially, or at least here in the Netherlands and the customers that I have, you really see that the organization that uses this technology and also the people that directly have to work with it also have to mature. They still have to learn, what works and what doesn't work technically, but also on, which use cases, how to build them, when to stop building them. If at some point really there's a feeling, all right, so there's no real business case for this. I think that is the biggest step that we're going to see in the next years. That doesn't really have to do with technology per se, I would say. More with the organizational maturity on this, on this subject,
which is a good thing. Well, and technology wise, do you think there are certain things that we can do right now that will change?
As one of the movements I see is this like SQL on data lake, way of thinking about it. So in the traditional Hadoop way, it was a lot of then became like data swarms as well. So you just put data in whatever form, and then people can use them, which is true, but it's still hard to do. But you see a lot, and also what we already for years advise is to put this SQL layer on top of it. You also see the same way of working, for example, by companies like Snowflake, a new service in Azure is called Synapse, which is also a SQL on data lake technology. So even though you store your data as CSVs or as Parquets, you basically start working with them as if it's a really big scale-out data warehouse, at least for your relational and semi-relational or semi-structured data. I think we will really see that more and more, and really see the data warehousing and data platform really grow towards each other. What I said.
So if I understand you correctly, saying that things like binning and partitioning of a data set that becomes more transparent to the user.
More automatic. Right now, there's still we put our thinking into it to optimize the data, how to organize it. I think at some point that will just be done by technology. And making it easier to use. You don't have to think as much. And I feel, at least for the analytics side of things, that we will also see more and more use of like drag and drop tooling. That already exists for ETL or for transformations.
Never. No, I'm joking.
So diehard engineers and data scientists, they always say that.
No, I actually don't agree with
the thing, I think the false promise of drag and drop tools is that you don't need to think about it anymore, and then I always say you can't deny complexity, you can't ignore complexity, and you cannot pretend that complexity, something that's complex, is simple.
I think that's
and just by using a different interface doesn't make something suddenly less complex.
So it's about the user, right? You need to understand it, if you can either drag and drop or code, it doesn't really matter as long as you understand what you're doing. Right?
What you typically see though is that people that can do that, most of them can code.
Yeah, that's interesting, right? So the thing is that drag and drop enables people who don't understand to actually do something in the system, and that makes it dangerous. But
so there's risk here for sure, and it's really, I think, so we will see this growth. I mean, it also happens for transformations, ETL solutions. For sure, it helps if you really understand what happens under the hood. But still, you could say, 50%, whatever type of challenges that you have can be solved in that way. Like in a relatively simple using drag and drop without fully understanding everything. It might not be optimized 100% either, but it's still being built and tested, and a lot quicker. And there's still this 50%, whatever, where you have to code because there's more complexity and you require more optimization of basically of the output. And in the end, it's also up to what quality. If you look at data science, probably what quality are you aiming for? Like, do you need like 80% accuracy? Maybe drag and drop brings you that, and it's good enough.
Yeah, maybe
you need more.
The danger I think is that that drag and drop is not going to be able to give you high accuracy. I think the problem though is that drag and drop, if you don't understand what you're doing, might give you a high number, and you fail to understand that it's not realistic, or you fail to understand that it will not generalize.
It's not. You can still build up technical depth using drag and drop.
Sure,
right?
sure. I also think that I take a little bit back my fierceness about needing to understand, because I don't think you need to understand everything, right? True. I don't need to understand how a computer works to understand how Microsoft Word works, right? And still be able to use it well. So you need to have an understanding to the level that it becomes not dangerous anymore to use
and
it.
for the teams that are implementing it, you need a good division of labor, or rather assignment of tasks of which team with which expertise builds what pipeline and what transformation.
And it's something that we grow towards, I would say, but not it will not totally replace engineers and data scientists, but it will be an easy place to start. And especially on the data science side, I totally agree. There are risks here because the output can be, hey, I'm 99% okay. But if you're measuring, if you're not evaluating it correctly, it gives this very false sense of how good it is. So there are risks there for sure. For transformations, it's a little bit easier. I want this and this to be joined, blah, blah. You can look at the output and say, yeah, this is exactly what I need. It's a little bit more transparent, more easier to evaluate, let's put it like that. But I really think, this will happen more and more, and we have to deal with it. And some of these technologies, I think, will be powerful, will accelerate some things.
I just thought of something cool. We could have GPT-3 generate data transformation. You only have to say, I want this database to be connected, this table and this database connected to to this database, and just
directly request a patent on this.
Pump it every 24 hours.
Patent pending.
Patent pending. You heard it here first, folks. Yeah.
But why can't GPT-3 not just build the entire data hub? But that's maybe a story for another time.
Because it doesn't really know what it's doing.
Well, do most people?
Yeah, true.
No, yeah, that's exactly what our value is. We use, at least on the Azure side, we use best practices. From Azure, on which services to use, how to configure them, how to do networking, the reference architectures on this. You could very easily say, hey, here they are. I actually have links also in training material for that. And this is and also in our sales material, this is what we use. This is what we base our work on. But that's so high level. When you really want to do it, there's this gap. There's always this gap between easy reading and really doing it, and then also automating it, making it foolproof and dummy-proof.
You're saying a tutorial is not enough?
No, the tutorial is not enough.
You have a Medium blog post on it.
Exactly. But that's where a lot of our value. It's not that we invented the entire thing. No, but we made it quick and usable, and really provides this quick start. And then continuous support. Whether it's not just the data, we can then continue doing projects on them, assisting the customer as long as they want us to help them with it.
You convinced me. I want to have a private data hub.
Me too. We'll get you one.
Okay, thank
you. If you give me a credit card.
This has been a lot of fun. Thank you. Thank you for talking to us and explaining
it was my pleasure.
And talking about the data hub. Ron, thank you for your questions and your insights as always. Thank you for listening. Did we inspire you? Tune in for the next episodes. Or visit our website, anchormen.nl. There you'll find more on bootcamps, AI masterclasses, or careers. See you at the next episode.